In this problem, I need to find the maximum amount of water a container can store using an array height of length n. Each element in the array represents the height of a vertical line drawn at that position, with the two endpoints of the ith line being I0 and I height of I. The task is to identify two lines that, along with the x-axis, form a container that holds the most water. Importantly, the container must remain upright and cannot be slanted. The algorithm used for solving this problem would be to first initialize two pointers left and right, then to calculate the area of the container. Afterwards, I update the max area value, move the pointers, and repeat this algorithm until the pointers meet. My ultimate answer is max area, which holds the value of the maximum area calculated. So, let's take the steps one at a time. For this problem, I decided to use a two-pointer technique. The two-pointer technique is a common algorithmic strategy which is used to solve problems that involve linear data structure, like arrays or linked lists. It involves using two pointers to traverse the data structure, typically from opposite ends, to find a solution. In the context of the problem, the two-pointer technique helps to efficiently find the pair of lines that form the container with the most water by moving the pointers inward based on the heights of the lines. This effective algorithm reduces the number of comparisons needed compared to a brute force approach. Now, in order to use this technique, I first need to initialize two pointers. In my case, I declared one at the beginning, which I called left, and one at the end of the array that I called right. In this step, I will also declare the variable that will conclude my final answer, max area. This variable is an integer that will store the maximum area encountered during the iteration. My ultimate goal is to maximize the area between the lines pointed to by the two pointers. Next, the algorithm starts the calculations of the area. The height of the container is determined by the shorter of the two lines, as the water level cannot exceed the shorter line. The width of the container is the distance between the two pointers. Therefore, the area is calculated as the product of the height and the width. Afterward, I compare the area I calculated with the value of max area, which is initially set to 0. This comparison will repeat for each area that I calculate. If the area that I calculate is larger than the value stored in max area, I update the variable to store the newly calculated area. To find the best possible solution, I need to adjust the pointers strategically. Since the area is limited by the shorter line, I move the pointer that shows the shorter line inward. This is because moving the pointer of the shorter line might lead to encountering a taller line, which could potentially form a larger area. I repeat this process of calculating the area until the left and right pointers meet each other. When they meet, it means I've considered all possible pairs of lines and max area holds the final answer. Finally, I return my answer. So, to conclude, by using the two-pointer approach, I efficiently and effectively reduce the problem from a potentially quadratic time complexity, the case in which I would consider all pairs of lines, to linear time complexity, ON. This makes it feasible to handle large input sizes efficiently. The algorithm ensures that I explore all possible containers and find the one that holds the maximum amount of water without the need for nested loops, which is a significant improvement in terms of performance. After all, the beauty of this algorithm lies in its simplicity and its efficiency. Now, I'll run this solution to make sure everything works properly before submitting.